This is definitely not a new topic, but in the interest of keeping podcasts short and manageable, I decided to put it in a different video. Make sure that you do not look at this video until you have first reviewed the first Hess's Law video, or this is not going to make very much sense to you. So this one is just a tough example with a lot of manipulations, and perhaps complex is the better word. It's not any harder than any of the things we did in the last video, it's just that we have a lot going on. So take a moment and read the problem and look at the reactions. You should kind of get a feel for this before you start trying to solve it or before you start following along with me. Our first step is always going to be to choose where to start. So we never want to have to guess. In other words, when you make a manipulation to any of these reactions, you want to know that it is the correct manipulation. So look at all of the reactants and all of the products. Now, if we start with equation 1, we can see it is the only reaction that has an NO2 in it. This is a great place to start since there is only one of them. We're going to need it to be in the reactants, and we only want one, even though our reaction has 2. So we're going to reverse this equation and divide by 2. We're reversing it to get the NO2 on the reactant side. We're dividing it by 2 to make sure that there's only one of them. Now, this can get a little bit messy kind of quick, so we're going to hold off on doing the manipulation until we talk through the next step. Now, let's look at the second equation. The second equation is a bit more complex to deal with. It only has intermediates and the NO in it. So you might say, let's deal with the NO. That's in our final reaction. Here's where that complexity comes in though, because you'll also note that there's an NO in both the first and the second reactions. So we might have to guess a little bit here, and maybe it's better to start with the next reaction down and just hold off on manipulating that one right away until we know for sure what we need to do with it. So we're going to just let this one alone for right now. Now, in the third reaction, we have an N2O in the reactant side. It is the only place in the 3 reactions where it's located, which means that this is another great starting point. Since it is already in the reactants, and there is 2 of them, all we need to do is divide by 2 to get that 2 down to 1. Because if you look at our final reaction, our reaction that we're trying to get to, there's just one of them. So it's on the right side, so we don't need to reverse it, but we do need to divide it by 2. Now before moving on, rewrite these 2 reactions on your own using the manipulations I said. Then go on and see if you got it right. And we'll deal with the second reaction here once we get to the next slide and we see what those look like. So when we reverse and divide the first reaction by 2, we get this. We reversed it, so our products become our reactants, and our reactants become our products. We divide it by 2, so we now have coefficients of 1, 1, and our oxygen was already a 1. So that is 1/2 now. Let's think about what we need to do with our delta H. When we reverse it, the sign changes. When we divide by 2, we divide the delta H by 2. And so we get this. I left it in this form so that you can see all the changes I made to it. Of course, you are welcome to just write out the calculation as well. Find the number and put it in. Now let's look at our third reaction. Here, we didn't have to reverse it. We only had to divide by 2. So we do the same thing to the delta H. We don't have to change the sign because we didn't reverse it. All we have to do is divide by 2 because we divided the reaction by 2. So now it's a little bit easier to see what to do with this other reaction, this reaction that we had ignored. If you look at the reaction that we had ignored now, and I have it included here as is for our benefit, we can look and see where all of the intermediates are and how we can make them cancel. And we can look at where the NO is and how we can get the appropriate numbers of NO3 on the product side. You can look at any of the 3 species in order to determine what to do. Theoretically, it shouldn't matter at this point since it's our last step you can look at any of them. But in our case, I think it's a good idea to look at all three and make sure that all three are telling us to do the same thing. So let's start by looking at the N2. The N2 is on the reactant side. Now, that's exactly where we need the N2 to be, because we want the N2 to cancel out. We don't have an N2 in the final reaction that we're trying to get to. And if you look at our two reactions that we have set up exactly how we want them, right now we have an N2 in the product side. We want that to go away. So far so good. We should just leave it alone. Let's see if the oxygen is telling us the same thing. For the oxygen, we also want it to cancel. There are no oxygens in our final reaction. So we need to make sure it cancels out. If we leave the reaction as is, we have one oxygen in our reactant side, and we have a total, you have to add them up, a total of one oxygen in our product side. That's perfect, they cancel out. So both of those tell us to do the same thing, which is to leave the reaction as is. Now let's make sure that our NO agrees with this. At the very end of all this, we need to have 3 NOs in our product side. Right now, if you look at what we have, we only have 1 in our product side. So we need 2 more. If we leave the reaction as is, that's going to give us another 2, which means we'll have 2 from this reaction, 1 from our very first reaction. That's 3 nitrogen monoxides, which is exactly what we want. So all 3 of these species tell us the same thing. They tell us to leave this reaction alone, to leave this reaction as is. Since we're not changing the reaction, we don't change the delta H, and we fill that in as is. Now, let's go ahead and rewrite all of these and very carefully cancel everything out just to make sure that we're okay, to make sure everything is exactly how we want it. So this slide is pretty much identical to the last one, just shift it around to give us a bit more room. Let's look at our oxygens first. We have half of an oxygen in the first reaction on the product side, half of an oxygen on the product side in the third reaction. And those 2 are going to be canceled out by the oxygen, the 1 oxygen in the second equation. So all of our oxygens are gone, which is good. That's what we want. Now let's look at our N2s. In the second reaction, we have an N2 in the reactant side, and we have an N2 in the product side on the third reaction. So those are going to cancel out. So now we just need to make sure that everything else adds up. We have an NO2 in our reactant side, and that's what we want for our final reaction. We have an N2O in our reactant side, which is what we want for our final reaction. And then on the product side, we have a total of 3 nitrogen monoxides, 3 NOs. And that comes from the first equation having 1 and the second equation having 2. So we have everything that we need. So all we have to do now is add up all of our delta H's. Be really careful again that you're adding up your manipulated delta H's, your delta H's that you've changed based on what you've done to your reactants and your products and your equations. And as long as you do that, you add everything up, you'll get your final answer.